Hi, fourth graders. We are back for lesson 78, classifying triangles. Classifying triangles. So we're going to take a look at three triangles that I drew up here. Okay. We have three basic types of triangles that we talk about. We say there's an obtuse triangle. Obtuse. Alright, when we think about an obtuse triangle, remember the word obtuse. The obtuse angles had those wide angles. So right here we have that obtuse angles. We think of something being obese, or it's big. Ob, big, obese. So obtuse, have that O start for that. Obtuse angle, that means it's more than a 90-degree angle. And a 90-degree angle is one that is also what we call a right angle, and it makes a little rectangle square. It makes more like a square in the corner if it were actually a right angle. Which brings me to the one that's right next to it. That is called a right triangle, not because it's right or wrong, but because it has that right angle. So it's called a right triangle. A right triangle is going to have that L shape, and it doesn't matter which direction it's pointing. It can be a triangle, let's say, that looks something like this. But right there's that right angle, so that's a right triangle. If we rotate it, it's going to come to be in the exact same position as that. So the right triangle has that little right angle in the corner, 90-degree angle. And then we have the third one, and the third one is called an acute triangle. Acute, we can think of it as acute triangle, like this one there, because all of the angles, or there is the smaller angles, all angles are acute. They're less than that 90 degrees, and they're small. So we say, oh, they're so cute. They're cute. So we call them acute triangle. They're smaller than that right angle. And that's what we would see as an acute triangle. Now there's a couple different types of triangles that we're going to talk about. And those triangles that we're going to look at is scalene, isosceles, and equilateral. So I'll start with the third one here, equilateral. You hear what it says there, equal. You can hear that, equal. So an equilateral triangle would have all sides the same length. So when I look at this acute triangle, and I look at the sides of each, they seem to be the same. Now, of course, we would use our handy-dandy ruler to make sure that they're the same sizes, and we would measure them, and they would come out to be the same. So equilateral triangles are those that have all three sides the same size. So we can have an equilateral triangle and an acute triangle at the same time. It's an equilateral acute triangle there. And isosceles, if we go up one, isosceles has two sides the same. Two sides the same. And I always like to remember this one by saying, okay, there's a pair right there, right? There's one thing in the middle of it, but it's a pair right there. Same with here, the E's, it's a pair. So we have a pair of pairs. Forget about the S on the end, just the two little pairs right there. So it helps me remember two sides are the same. And if I think about two sides being the same, let's make another triangle here. And let's do it with ruler, and we'll show you what that isosceles triangle might look like. So I'm going to go from 5 to 6 on my ruler, and then I'm going to take it from here, and I'm going to go from 5 to 6 again. So I'll take that down like that. 5 to 6, 5 to 6, and then I connect them together, and they're not going to be 5 to 6, it's about half that size. Connect them together. Now I know that this side and this side are exactly the same, but this side is different. So I have two sides the same, one side different. That makes it an isosceles triangle. And then we look at the last one, which is a scalene. A scalene triangle has all three sides different. Three sides different size. All right, kind of got that in there, I think. All right, three sides, all different sizes. So when you do that with your ruler, that makes it easy because we can just say, okay, I'm going to pick a number here, I'm going to pick a number there, and then I'll connect it. So let's start with, let's do a 2-inch side over here, and then let's do a 1-inch side over here. Oops, a little bit off. And then when I go over here, this is more like a 1.5 or 1.25 inch side, and I make sure that it's not the same as the other two. And when I make that triangle, that's considered a scalene because this side, and that side are all three different sizes. All right, oops, looks like I took out a little bit of this. Equilateral. The other thing about equilateral triangles is sometimes we might call them equiangular. Equiangular means that those angles are all the same as well as those sides. But this here we see is a scalene. All three sides are different as far as their sizes. I want you to look in your books, okay, on page 497, and let's just kind of go through a few of these things. It says, draw a triangle that is both a right triangle and an isosceles triangle. A right triangle and an isosceles. And that would be like what I have up here. It's a right triangle, and then if I measured them, there would be two lines that are the same, but this line is different. So that would be a what we call a right triangle and an isosceles, because an isosceles would have two lines that are the same size. Okay. On lesson practice on the next page on 498, it asks us some questions. Can a right triangle have two right angles? Well, can a right triangle have two right angles? What do you think? Well, I'm going to test it out for you. So remember, if we take that triangle and we lay it straight out, if we just take it and lay it straight out, that triangle, that's 180 degrees. So our triangle angles have to equal 180 degrees. So if I start with a right angle, and that's 90 degrees, could I have another 90 degrees? This up here, if I connect them, does that look like it has a L shape to it? Nope, because it would have to come out that way. This one would have to go up that way instead, and that doesn't work. If I have two right angles, I probably have a rectangle then, or I would have four right angles, right, and get a square. But that is, so the answer to that question is definitely no. We can't have two right angles on a triangle because they have to equal 180 degrees, and it's only 90 degrees here, so I have, this should be a 45 degree angle, and this should be a 45 degree angle. It would be too much if I did anything more. What is the name for a triangle that has at least two sides of equal length? Remember that word down in the bottom corner here? Isosceles. Isosceles triangle. Okay. And finally, they're going back to that translation, reflection, rotation. So what they want you to do is think about taking an object and rotating it. Take an object and translate it. Take an object and reflect it. So if I have my pen, let's go and I'll show you examples of all of these. This kind of reviewing what we had before. So if I have this pen, here it is. If I'm going to translate it, remember translation means just to move it over to the different language. Like I said, translation, we're just moving it. It's going to be the same, just moving it. Okay, I translated it right there. That's a translation. It was here, now it's here. Here to here. All of those are translations. A reflection. Reflection, we want the opposite of what we see here. So if I have this, a translation, or let's do a reflection we're doing. Reflection then is like this, right? Because I flipped it from one side to the other. And first it's the colored and then it's the white with the name on it. But when I see the reflection, it's the color and then the name on it. Okay? And to have a rotation, we're going to pick one point, and one point is going to stay the same and the others are going to go around. So when I rotate, kind of like the center of a clock, and this is the arm on the clock, it's rotating. Okay, so that's just the review of that rotation, translation, reflection. All right, so three types of triangles. Isosceles, which has two sides that are the same. Then there was the scalene, which is all three sides different. For the scalene one, I say I only want to get on the scale once to see how much I weigh. So that's how we remember that. You only have to get on the scale once to know what you weigh anyway. And then equilateral, you just hear it in the word equal. All sides equal on that triangle. Okay? Your lesson worksheet should be in your packet. And hopefully you guys are doing well. And like always, let me know if you have any questions.